exponential growth and decay, as well as solving some exponential equations and inequalities, some basic ones today. Okay, so for an exponential function is any function whose equation is written in the form y equals a times b to the x power. So in order for it to be an exponential function, notice that x is an exponent. So if you have x as an exponent, it's an exponential function. X is an exponent. That makes it an exponential function. Okay, now we have 4 functions that are exponential that we do need to graph. So looking at problem number 1, it says to use the calculator to sketch the graph. So when we're sketching a graph, we're not going to put point per point per point. We're just going to look at the calculator screen and just sketch what it looks like on our graph. So number 1, we have f of x equals 2 to the x power. Is that an exponential equation? Is x an exponent? Yeah, so that one is exponential. So to type it in the calculator. Now, if you already have a graph on your calculator, how can you clear it? Doc B will clear it. Doc B will clear it. Now, go back to the calculator page, and we need 2 raised up to the x power. So 2 raised up to the x power. Then if I hit enter, there's a graph. We're just going to sketch what it looks like. So notice the left side is near the x-axis and the right side is going upward. Looks something like that. Then for number 2, we have f of x equals 3 to the x power. So if I go back to my calculator, how can I clear this? Doc B will clear it. Go back to the calculator page, and 3 needs to be raised up to the x power. And when I hit enter, what does it look like? What's happening with the left side? It's on the x-axis, and yeah, this one, the right side, it's still going up, but it's a little bit steeper than 2x. So the left side is still on the x-axis, but this one is just a little bit steeper. Now, both of these are called exponential growth. And you read a graph from left to right, just like you read a book from left to right. So from left arrow to right arrow, what's happening to this function? Going up. Same thing for this one. From left arrow to right arrow, what's happening? Going up. So if it's going up or growing, this is called exponential growth. So it's going up from left to right. Then number 3. Now we have f of x equals 1/2 to the x power. Is that an exponential function? Is x an exponent? Yes, it is. So go ahead and type that one in. How can I clear my calculator? Doc B. Now notice on your handout it had parentheses. So go ahead and put an open parenthesis. And then control divide for a fraction. 1 on top, 2 on bottom. Close the parenthesis, and raise it up to the x power. So f of x equals 1/2 to the x power. And if I hit enter, here's the graph that we need to sketch. Now this time, the left arm is going up, and the right side is approaching what? The x-axis. So go ahead and sketch that one. Left side is up, right side is approaching that x-axis. Then problem number 4, we have f of x equals 0.9 to the x power. Is that one an exponential function? Yeah, because x is an exponent. So to put that one in the calculator, first, how do I clear this? Doc B will clear it. Go back to the graph, and we need 0.9 raised up to the x power. Was that the right equation? Yeah. So when we sketch that one, it's going to definitely look different. The left side is still going up, and the right side is still going towards the x-axis. It's just not as prominent or pronounced as that one. Now, from left arrow to right arrow, what's happening to these functions? They're going down. They're decreasing. So both of these are called exponential decay. So if it's going up, it's exponential growth. If it's going down from left to right, it's exponential decay. Now, from the equation, you can easily tell whether it's exponential growth or exponential decay. And from your equation, we'll go ahead and go to the next one. For our exponential equation, I had you right at the top with y equals a times b to the x power. Now for exponential growth, that means the b value has to be a number bigger than 1. So that means this number right here that has the x exponent has to be a number bigger than 1. So if you look back at that first graph, what was the equation? It was f of x equals what? 2 to the x. Is 2 bigger than 1? Yes. What was the next equation? F of x equals 3 to the x. Is 3 bigger than 1? Yes. So if that number with the exponent is bigger than 1, then it's going to be exponential growth. Now for exponential decay, that means your b value is a number between 0 and 1. So if you look at that third graph, it was f of x equals what? 1/2 to the x power. Is 1/2 between 0 and 1? Yes. And for that last equation, what was the number? 0.9. Is 0.9 between 0 and 1? Yes. And then something I didn't mention, the a value is your starting amount, and sometimes we call that the initial amount. So the a value is the initial amount. The b value is either your growth or decay factor. And we'll have some practice with that equation here in just a moment. Okay, so next example. We need to determine whether each function is exponential, and if it is, we have to decide is it growth or decay. So looking at equation 5, is that one exponential? Yes. Why is it exponential? X is the exponent. So this one, yes, is exponential. So if it is, I have to decide is it growth or decay. So to determine that, we have to look at this b value. Is that a number greater than 1 or a number between 0 and 1? If it's between 0 and 1, it would be decay. So this one is exponential decay. And then number 6, is that one exponential? Yes, because x is an exponent. So yes, this one is exponential. If it is, you have to decide is it growth or decay. So look at this value right here. And is that number bigger than 1 or is it between 0 and 1? So if it's bigger than 1, is that growth or decay? Growth. Number 7, is that one exponential? Why not? Yeah, the x is not in the exponent. If the x were right here, yes, it would be. But it's not. We have a 5 right there. So this one is not exponential. It's not exponential because x is not an exponent. And number 8, is that one exponential? Yes, because x is the exponent. So if it is, we have to decide, would this be growth or decay? So look at this value right here. Is it bigger than 1, or is it a number between 0 and 1? So if it's between 0 and 1, would that be growth or decay? Decay. So this one would be exponential decay. Okay, now we have some word problems, but they're pretty simple, pretty straightforward. It's just using this formula. Okay, so for number 9, it says that Tony purchased a rare 1959 Les Paul guitar in 2000 for $12,000. Experts estimate that its value will increase by 14% per year. Write an exponential function to find the value of the guitar in 2012. So what we need to do is come up with our exponential function. Y equals A times B to the x power. Now, anytime you're talking about a percentage rate, the B value is going to be either 1 plus R or 1 minus R. It depends on, is it growing or is it decaying. So that's the second function. Anytime you have a percentage rate, use this one. So that should have been an extra equation they should have given us. So if you have a percentage rate, your B value will be 1 plus R. So R is your percentage rate. So using this bottom equation, this would be Y equals A is your starting amount or initial amount. So what was the starting value? $12,000. So A would be $12,000. Inside the parentheses, we're either going to have 1 plus R or 1 minus R. But they said that the value is increasing. So this would be 1 plus the percentage rate. So what is our percentage rate? 14%. Change it to a decimal. So 0.14. And X is going to be your time in years. 12 is right. Where did 12 come from? Yeah, we started in 2000, but we're looking for 2012. So how many years passed by from 2000 to 2012? 12. Okay, I don't expect you to be able to do that in your head, so definitely use a calculator. Make sure you're not on a graph page, so just go to a sketch pad on a calculator page. It needs to be 12,000, parenthesis, 1 plus 0.14, $12,000, 1 plus 0.14, raise it up to the, how many years? 12 power. There's our value. Now the thing about your Inspire that I don't like is that it does some crazy rounding. So what I want you to do is arrow up 1 time, highlight your answer, and hit enter. What happened when I did that? Notice it expanded that value. So what you need to do is you need to expand your value each time. You did 1 plus 14. That should be 1 plus 0.14. Okay, so now my answer needs to be in money. So this is $57,814. 57,000, was it 814? Now I have to figure out how many cents. So if I'm rounding for money, how many decimal places do I need? 2. So make sure for money you have 2 decimal places. So behind the decimal place I see an 85, but behind that 85 it's a 7. So does it round up or stay the same? Rounds up. So instead of 85, it rounds up to 86. So it's $57,814.86. Now, was that hard? No, it's just using a formula, putting numbers in the correct place. Next one, number 10, it says that the value of a truck bought new for $28,000 decreases 9.5% each year. Write an exponential function to find the value of the truck after 5 years. So for a percentage rate problem, it's going to be y equals a. Inside the parentheses, it's either going to be 1 plus r or 1 minus r. What's the key word in this problem? Decreases. So should I add r or subtract r? Subtract r. And then that would be to the x power. So this would be y equals a is the starting amount. So what was the starting amount? 28,000. Inside the parentheses is 1 minus, and r is the percentage rate. And what is the percentage rate? And what is 9.5% as a decimal? 0.095. And x is the number of years, and they told us this was for 5 years. Again, I don't expect you to be able to do this without a calculator, so definitely type this in. So make sure you're not on the same line as that previous answer. So this was it 28,000? And then parenthesis 1 minus 0.095. Close the parenthesis. Raise it up, and how many years did we have? 5. Now again, you're inspired. It does some rounding. But if you're talking about money, we need more than one decimal place. So highlight the answer and hit enter once your answer is highlighted so it can expand it for you. So our answer needs to be $16,998. And for money, how many decimal places do I need? 2. So let me go back. And behind the decimal, I see a 12. Behind the 12 is a 1. So does it round up or stay the same? Stays the same. So this would stay at 12. So $16,998.12. Number 11. Let's see, an acidophilus culture containing 150 bacteria doubles in population every hour. Write an exponential function to find the number of bacteria after 12 hours. Okay, so this one. Does this one have a percentage rate? No, so this is just going to be y equals a times b to the x power. So no percentage rate, it's just the exponential function. Y equals a times b to the x power. So this would be y equals a is your starting amount. So how much bacteria did we start with? 150. And then b is going to be our growth factor. So this bacteria is growing by what factor? Where'd 2 come from? It doubles, so that means it's multiplied by 2. Now, x is going to be how many times does it double? So it says it doubles what? Every hour for how many hours? So what do I put for x? 12. This one also, I would not expect you to do this without a calculator, so just type this one in. So make sure you get out of the answer. So this would be 150. 2 in the parentheses, raised to the 12th power. Now, this is bacteria, so do I need to have any decimals here? No. And if it's doubling, will I have decimals? No. So this would be 614,400. 614,400. And I need some units here. The other answers I put money. But what are we talking about here? Bacteria. So 614,400 bacterium. Now, we're going to be doing a little bit of solving. So we need to solve each exponential equation or inequality. So number 12, we have 4 to the x power equals 64. Now to solve these easily, we're going to get a common base. What does common mean? Same. So over here, what is the base? 4. I want to have the same base over here. So 4 to what power would give me a 64? 3. Right? 4 cubed is what? 64. What does this symbol right here mean? Equal. So if my bases are equal, what does that tell me about the exponents? They're equal. So my answer would be x is equal to 3. So if the bases are equal, the exponents are equal as well. Now, was that one hard? No, it's going to be pretty simple. Next one, number 13. Are the bases the same? And what does this symbol in the middle mean? Equal. So if the bases are the same, what does that tell me about the exponents? They're equal. They're the same. So take your exponents, which is x plus 1, set it equal to 2x plus 3. So if the bases are equal, the exponents are equal. Solve for x. Now this one does require a little bit of math. So what will we have to do to solve for x? Subtract x to both sides. So that gives me 1 equals 2x minus 1x is x plus 3. What do I do next? Subtract 3 to both sides. 1 minus 3 is negative 2 is x. Next one. Do we have a common base? No. For the left side, what's the base? 3. So on the right side, I want to have a common base. I want to make 27 have a base of 3. So 3 to what power equals 27? 3. 3 cubed is 27. So if the bases are equal, what does that tell me about the exponents? They're equal. So what's my answer? X equals 3. Okay, now instead of an equal sign, now we have an inequality symbol, but we're going to work it the same. We want to get a common base. Well, over here we have 81. Here we have a 27. So we'll have to figure out what could we get for a common base between 27 and 81. 9 to what power would give me 81? 2. 9 to what power would give me 27? That won't work, will it? But that was a good start. That was good to start. But it's not going to be 9. Any other ideas? Three. 3 to what power would make 81? Mm-hmm. 3 to the 4th power. And then we have our less than or equal to. Now for 27, I'm going to put 27 in parentheses. What could I use for 27? Well, I know the base needs to be 3. But 3 to what power gives me 27? 3. And then on the outside of 27, we have the exponent, which is x minus 1. Now, do we have a common base? Yes. When I had the equal sign, what did I do with those exponents? Set them equal, right? But do we have an equal sign? No. So instead of setting them equal to, I'm going to set them less than or equal to. Now, over here, we actually have 2 parts for the exponent. We have the 3, and we have the x minus 1. And this is actually power to a power. So when it's power to a power, what do you do with these? Multiply. So the 3 needs to be multiplied by x minus 1. So power to a power, you multiply. Now go ahead and distribute our 3. Why did I what? This was 3 to the 4th power. The 3s, kind of think of that as canceling. So the bases kind of cancel because they're the same, right? So it's just the exponent. So the 4 drops down, and here the exponents drop down. Good question. Okay, so bring down the 4. Distributing the 3, what's 3 times x? 3x. And what's 3 times negative 1? Minus 3. What's next? Add 3 to both sides. What's 4 plus 3? 7 is less than or equal to 3x. What's the last step? Divide both sides by 3. So we have x. We still keep the less than or equal to 7/3. Is that the common way to write my answer? Normally what should go first? X. So if I switch these, what else needs to switch? The symbol, instead of a less than or equal to, it needs to be a greater than or equal to. So notice the symbol pointed to the 7/3, so make sure you flip it so it still continues to point to the 7/3. Okay, number 16, we have 6 to the x equals 1 over 36. Now to solve these, we need to get a common base. So what do you think a common base would be between those? 6. So this one is 6 to the x. That one's good to go. What about 1 over 36? This would be 1 over 6 what? Squared. But I need to get rid of the 1, so what I'm going to actually have to do is send this to the top. And what happens to that exponent when I move it to the other side? The positive 2 changes to a negative 2. So another way to write 1 over 36 is 6 to the negative 2. So you need to get rid of your fraction, so move it to the other side of the fraction. Now, are the bases the same? So if the bases are equal, what does that tell me about the exponents? They're equal. So what's the answer? X equals negative 2. So think of the bases as kind of canceling, and then the exponents are equal. X equals negative 2. Next one. Do we have a common base? Yeah, we could get a common base of 6. So this would be 6 to the 2x minus 1. And this would be 1 over 6 to what power gives you 216? Three. 6 cubed. But now I need to get rid of the 1. So how do I do that? Move this to the top, and what happens to that exponent when I move it to the other side? Becomes negative 3. What's next? What happens with these bases? They kind of cancel, so drop down your exponent. So this would be 2x minus 1 is what? Greater than negative 3. The 6's, think of the bases as canceling. So the 6 and the 6 cancel. What would I do next? Add 1 to both sides. So that would be 2x is greater than negative 3 plus 1 would be negative 2. Divide both sides by 2, we get x is greater than negative 1. So x is greater than negative 1. Okay, I want you to try number 18. I want you to get a common base between the 8 and the 2. So work with the 8 and the 2, get a common base between the 2. common base between 2 and 8? 2. So 2 to what power gives me 8? 3. And the right side is good to go. What happens with these bases? Basically, they cancel. So that gives me 3x equals x plus 6. So power to a power, these were multiplied. 3 times x is 3x. To solve for x, what's next? Subtract x to both sides. What's 3x minus x? So 2x equals 6. Divide both sides by 2, and x equals 3. Okay, number 19. We need to get a common base. What would a common base be between 4 and 32? 4 to what power gives you 32? Nothing, that won't work. 2. So I want you to work number 19. I want you to get a common base with a 2 in it. So you work number 19. Get a common base of 2. 2 to what power gives me 4? Squared. So 2 squared is 4. And then we have the x minus 2. And 2 to the what power gives me 32? Fifth power. 2 to the fifth power is 32. What happens with those 2's? Basically, they cancel. So what do I do with these exponents? Power to a power, I multiply. So 2 needs to be multiplied by x minus 2. And 5 needs to be multiplied by x plus 1. So power to a power, you have to multiply. Distribute the 2. What's 2 times x? 2x. And what's 2 times negative 2? Negative 4. Distribute the 5. Huh? Yeah, 5 times x would be 5x. And 5 times 1 plus 5. What's next? Subtract the 2x to both sides. So negative 4 equals 5x minus 2x is 3x plus 5. Subtract 5 to both sides. This would be negative 9 equals 3x. And divide both sides by 3. And what does x equal? Negative 3. Number 20, what would be the common base between 9 and 27? 3. So for 9, what would I put? 3 squared, and then 8 minus x. And for 27, that would be 3 to the third power. Then we'll have x minus 3. What happens with those 3? They cancel. And power to a power, what do I do with those exponents? So this would be 2 times 8 minus x equals 3 times x minus 3. Distribute the 2. What's 2 times 8? What's 2 times negative x? Minus 2x. Distribute the 3. 3 times x is 3x, and 3 times negative 3? Negative 9. What's next? Add 2x to both sides. So 16 equals, what's 3x plus 2x? 5x minus 9. Add 9 to both sides. 25 equals 5x. Divide both sides by 5. And the answer is 5. X equals 5. Okay, one more. Last one, number 21. What would be the common base? 2, so the left side is good. But instead of 8, that would be 2 to what power? 2 to the third power. Can I leave it like that? No. To get rid of the fraction, send this to the top, and when I send it to the other side, what happens to that 3? Changes to negative 3. What happens with my 2's? They cancel. So this would be 3x minus 12 is greater than, what do I do with the negative 3 and x? Multiply, so negative 3 times x would be negative 3x. What's next? You want to add 3x or subtract 3x? Subtract 3x to both sides. Either one would work. So that would give me negative 12 is greater than negative 3x. Negative 3x makes negative 6x. How do I get rid of the negative 6? Divide both sides by negative 6. And when I divide by negative, what do I have to remember to do? Flip the sign. So instead of a greater than, it changes to a less than. What's negative 12 divided by negative 6? 2. Shall I leave my answer like that? No, what should be first? So if I switch these, what else switches? The less than switches to a greater than. So it's pointing to the 2. I need to make sure it still points to the 2. So make sure you flip the symbol one more time.